Good afternoon, friends. Today we will be discussing the kernel, what is the kernel, and system calls. Along with, we will be discussing the system initialization. So, in this video, we will be discussing the full the OS working, how the OS operating system works in a computer system, how it deals operation, how it performs, how it manages the hardware and software resources of a computer. So, without any wastage of time, let us get started. So, what is the kernel? A big question that comes in our mind, that what is a kernel in operating system, what is it is working, what are its features, what are its characteristics. A kernel is the core component of an operating system. It is the primary interface between hardware and software, that is, between the applications and the hardware. Okay, the kernel handles low level operations like process management, memory management, file system control, device handling, input output registers. Okay, so it acts as a boss. Whenever a user interacts with the system, he has to interact with the operating system, and operating system, there is a main, actually a gatekeeper there, which is called kernel, which handles all these operations. While you want to retrieve or read data from a memory, or you want to your number of processes can be handled by the kernel, or memory management or your security is handled by the kernel. So I think you have got an idea about the kernel. Let us discuss why we need kernel. First main thing is that user level programs run in user mode. Some, as we know that our user level programs, like we are running an application, it runs in a user mode with limited privileges. So to prevent them from directly accessing hardware or operating system internals, we need a kernel. So kernel is basically a gap, a bridge between the user and the operating system, the main system between the hardware. Suppose a user is working on a file that is infected with some virus. So if the file gets write or gets saved into the operating system, then definitely this one is actually hazardous for all the our system, and our operating system will crash. So how this is being handled? This is being handled by the kernel. So that is the first case. So it means that our kernel has some privileges which a user does not have. Second thing is that kernel runs in kernel mode, as I told you. That is the some privileges, that is in privileged mode. That means it is able to safely perform hardware access and critical operations. Those operations that can only be done by the kernel, and it cannot be interfered by the user. So that's why there is this kernel mode. That's why we need a kernel for those operations, some critical operations. Third main reason of why we need kernel in our system, in our operating system, is that this separation between the user with the hardware, this ensures security and stability. User program cannot crash or corrupt an operating system. That's what I told you before, that why we need kernel. Kernel handles these. Kernel provides us the security as safety, okay, so that our operating system cannot crash. So let us discuss about what is a system call. So what is this system call? We learn about kernel. Now what is the system call? System call is a programmatic way for a user level program to request a service from the operating system kernel. So in order to interact with the kernel, we need some functions. We need some we can say a tool like thing, a gateway. So we need system calls. So system calls here plays a role. So system calls are actually the a way to interact with the kernel. Okay, that are actually handled by the user. That are actually programmed by the user. As user can interact using different system calls that we will discuss later. And with the help of these system calls, they can interact with the kernel to perform some requests, to perform some operations, to use the operating system, to use the machine actually. Okay, so it is the only valid entry point into the kernel from user space. So in order to interact with the system, a user wants to interact with the hardware. How he will interact? He will interact with the kernel using his system calls, using as functions, using a programmatic way. User programs cannot directly perform privileged operations or access hardware. Okay, so this is the thing. User programs cannot directly perform privileged operations or access hardware. Those privileged operations can only be done by the kernel. Okay, or those the hardware can be only accessed by the kernel, and the user can access the hardware through the kernel with the system calls. Now, how system calls work? That we let us discuss the mechanism of system calls. First thing is, when a program makes a system call, the CPU switches from user mode to kernel mode. For example, you want to get some file from your operating system, from your like mobile phone. You want to read some let us say PPT file from memory. How will you get that? You will click by the help of GPUI, that's a graphical, sorry, GUI, that is graphical user interface. You will click on that file, and when you click on the on that file, it gives the request to the kernel with the system. At the back end, it is happening with the programs. With the help of programming, you are using the open or read system call, which we will discuss later, and that system calls goes to the kernel, and the kernel here performs switches from user mode to the kernel mode and perform some operations, and after performing some operations gives us the file back, and then after the operation is done, it comes back to the it is user mode. That's how the context switching is being here performed. Okay, second thing is that kernel handles the request, performs the operation, for example, file input, output, process control, or memory allocation. Then returns result to the program and switches back to the user mode. That's what I told you. This mode switch plus handler plus return, यानी कि that means I can say कि ये जो कर्नल है पहले यूजर मोड से होके ये कर्नल मोड में आता है, ऑपरेशन परफॉर्म करके वापस आता है यूजर मोड में. तो ये जो स्विचिंग होती है, ये क्या करता है, एंश्योर रिक्वेस्टेड ऑपरेशन इज डन सेफली एंड अंडर कंट्रोल ऑफ द ऑपरेटिंग सिस्टम. This is how the system calls work. Let us discuss some types of system calls in operating system. We have a different types of system calls. A process control. What is a process control? It is the system calls are being used for creating, managing, and terminating process. For example, creating a new process, loading a program, ending a process, waiting for a child. So this is all is done by the system calls. For example, fork function, execute function, wait function, exit function. These are all the system calls for process control. Same is the case with system call. There are system calls for file management, allowing programs to interact with files, including opening, reading, writing, closing, renaming, and deleting files. We use open func system call, read system call, and write system call. Okay, this all actually seems confusing for the user who is using his system, operating his computer system. He or she may think that how it is done. It is done because it is done at the backend level. You have GUI, graphical user interface, and which gives you the only the necessary operations. Like when you click on the any file in a file explorer, let us say on a phone, when you click on that, there is a system call that goes at the back end. It gives request to the kernel, and kernel moves from user mode to the switches from user mode to the kernel mode, that is the privileged mode, and performs some operations. Finds that file कहाँ है वो, किधर है वो, फिर वापस आके उस फाइल को हमें देगा. अगर वो फाइल होगी मेमोरी में, वो वापस देके हमें फिर से यूजर मोड में आके हमें वो फाइल प्रोवाइड करेगा. ये होता है बैकएंड पे. इसी तरह memory management, there are in the memory management there are system calls. In the device management, you see there is read, write, open, same file, same system calls. that controls interaction with hardware and devices through drivers used for requesting or releasing a device and sending commands to hardware. This is done through the device management system calls. Same is the case with information maintenance, but little bit different. Suppose you want to retrieve or update a system information. For example, you want to get system time or process ID or file metadata or resource usage. You use get PID, that's a get process ID uh, system call, or get process parent process ID system call, or uname, that is the undirectional name system call. Okay. Okay. Lost system call is the system call comes in the inter-process communication. For example, two processes want to share some memory to each other. They use the system calls like pipe function is here, shm get function, and message send function. These are the some system calls. So let us. There is a question that comes in our mind, which is the a quick question, basically short question. That is, what is the difference between a system call and a library call? So a system call enters the kernel, executes in kernel mode, and privileged operations are being allowed. And when it performs, and the kernel comes back to the user mode. This is a system call. System call is basically the call is basically a function that executes in the kernel mode and then comes back as a response. While as a library is a normal function libraries, a normal function in libraries that runs in user mode, not in a kernel mode, but only in a user mode. No privilege escalation or no hardware access. I hope you got the difference between the system call and library call. System calls are slower because more context switching overhead is here, but necessary for operating system level tasks, OS level tasks. Okay, but what about the library call? They are lightweight and portable, but limited. So this is the difference between the system call and library call. So there is one more topic, that is system initialization, which we also call booting or initialization process. Now see, when a computer boots, what do we mean by booting? It means when we power on our computer system, the operating system kernel is loaded and initialized. One of the kernel's first job is to launch the initial, that is, or init process. Okay, this first process, often with process ID 1, becomes the ancestor of all the processes. It sets up system state, launches daemon services, handles further process creation. So this is actually the ancestor for all the processes when we want to, whenever we power on our system. Okay, so our first process, the main job of the kernel is to first initialize or launch the init process, which is actually the ancestor of all the processes. So without successful initialization and launch of init process, the system cannot proceed or to normal operation. Boot would fail. When we say booting of our computer system, that fails because of the initial process, which is the ancestor process. Now, in the summary, we have discussed the kernel, system calls, system initialization, boot initialization, and at the end we understand how the operating system, the main kernel role, how it helps you to appreciate the abstraction, security, efficiency, and manages hardware. So I think this is all for this in this video. We will meet in next video. Till then, goodbye.